Hi, friends. It's Miss Allie. Today, I'm super excited. It is a special day. We are going to focus on some application problems, and we are going to get to do some application problems together. So, our I can statement, our learning target for today says, I can explain my thinking using pictures, numbers, and words. If we unpack that learning target, pictures, numbers, and words, we know what those words mean. But in math, it means when we are writing our answer, we are including pictures in our answer, like these dots. We are including numbers in our answer, like these numbers here, writing expressions. And we are using words to show our thinking in our answer. So we are explaining our thinking. So that's what our learning target means. It means when we answer a question in math, we can explain our thinking. We can show in our answer pictures, numbers, and words. So we're going to practice that today. The materials you're going to need today are a whiteboard and a whiteboard marker. And we're going to get started right away with our application problem. Our first application problem. So you can see I have my whiteboard here, and I'm going to be answering this question with you. So the first one says, Blake says that when the unknown is 5, it makes this number sentence true. 2 plus 5 equals blank plus 2. Brendan says she's wrong. He says 7 makes the number sentence 2. Who is correct? Explain your thinking using pictures, words, or numbers. So we're going to use all three. So I'm going to show you my thinking. So the first thing I have to figure out, the first thing I'm going to do is draw a line down the middle. Because Blake thinks one thing and Brendan thinks something else. So I'm going to write Blake on one side and I'm going to write Brendan on the other side. Blake thinks that when the blank is 5, it makes it true. All right, so let's try solving that. So the number sentence says 2 plus 5 equals blank plus 2. I'm going to put that on Brendan's side too, because we're trying to figure out who's right. So let's see. Blake thinks that it's 5. So I'm going to put the 5 here, and then I'm going to solve. So I'm using pictures. So I've used some numbers, and now I'm going to use some pictures. I have 2, and then I have 5. So I know that together that's 7. And on this side I have 5, and I have 2. So that's 1, 2, 3, 4, 5, 6, 7. So that's 7 too. We've learned this as the commutative property. 2 plus 5 equals 5 plus 2. So I think Blake is correct because I know that 7 is the same as 7. 7 does equal 7. So I'm going to write the word correct. And it says it right in the application problem here, correct. So if I don't know how to spell correct, that's okay. Brendan thinks it's 7. So now I'm going to solve with it for 7 to see maybe Brendan's correct too. So we already showed dots before, but I'm going to show them again. 2 plus 5 is 7. 7 plus 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 equals 9. That's not correct. So I'm going to make an X. No. I'm writing the word no. Brendan's wrong. So just to show my point again, I'm going to write Blake is correct. This is what we expect to see when you're showing your thinking. Everything that's going on in your brain, we want you to put on paper. So now I'm going to go through my checklist. And I'm going to think, do I have pictures? Yup. It looks like I have pictures. Check, check. Do I have numbers? Yes, I have lots of numbers. And do I have words? Yes, I have lots of words. So I've explained my thinking using pictures, numbers, and words. All right, friends, let's try another one. This one says, Drew says that 4 and 2 is equal to 2 and 4. Lena says he is wrong. Who is correct? Explain your thinking using pictures, numbers, or words. So I'm going to figure out Drew's thing first. It says Drew says that 4 and 2 is equal to 2 and 4. So I'm going to write that. Drew thinks 4 plus 2 is equal to 2 and 4. So let's see if he's correct, because then we'll figure out if Lena's right or not. So first I'm drawing my dots, and it shows 1, 2, 3, 4, 5, 6. Then it shows I have 2, and I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 6 equals 6. So I know that this is true. Another way that I could show this is by making a number bond for each side. So if I have 4 plus 2, I know the total is 6. And if I have 2 and 4, I know the total is 6. So I know that 6 equals 6. That's what Drew said. Lena thinks he's wrong, but Lena's wrong. Drew is right. So I'm going to write Drew is correct. And now I'm double checking that I've used pictures, numbers, and words. So I have my pictures. Number bonds count as pictures too. I have numbers and I have words. So this is what we expect. We expect you to show your thinking so we know what's going on in your brain. Let's try another one. This one says, Kira tells Julian that 7 equals 7. Julian says she's wrong. Who is correct? So let's think about Kira's thinking. She said 7 equals 7. So I wonder, let's put 7 circles. 1, 2, 3, 4, 5, 6, 7. And now let's put 7 squares. 1, 2, 3, 4, 5, 6, 7. There is the same amount in each of these. Here I have 4 plus 3 equals 7. Here I have 4 plus 3 equals 7 because I have 4 on top and 3 on the bottom. So I can see that 7 equals 7. And that's what Kira said. So Kira is correct. I'm going to write that. Kira is correct because this is her thinking. So now I'm going to double check to make sure I have pictures, numbers, and words. I got my pictures, I got my numbers, and I have my words. That's how I'm going to solve this application problem. I want to see all of your thinking. Let's try another. This one says Tommy decided to give 6 Oreos to his friend Amelia. Amelia put 2 Oreos on her plate and the rest in her lunchbox. How many Oreos did Amelia put in her lunchbox? Explain your thinking using pictures, numbers, and words. All right, so first I'm going to draw the 6 Oreos. 1, 2, 3, 4, 5, 6. Because Tommy gave Amelia 6 Oreos. Amelia put 2 Oreos on her plate. So I'm going to circle 2 Oreos and I'm going to remind myself that this is her plate. So I'm going to put a P, plate. The rest of them went into her lunchbox. How many Oreos did Amelia put in her lunchbox? So I'm going to draw the rest of them in her lunchbox, and I'm going to make an L for lunchbox. I can tell that there's 4 Oreos in her lunchbox. 4 in, and I'm just going to copy from the screen. Lunch box. All right, so let me check. Did I use pictures? Yes, I got my pictures. Did I use words? Yep, the P and the L count as words, and so does this sentence. I'm noticing I didn't use numbers. So I need to go back and add my numbers to the story. So there's 2 over here. And we were trying to figure out how many were in her lunchbox because she had a total of 6 Oreos. So I know there's 4 over here. So she has 4 in her lunchbox. And I'm going to put that 4 in a box, just like this. Now I have my numbers. This is perfect. This is exactly what we're looking for when you solve this kind of application problem. All right, friends, so your task for today is to complete the following application problem on a whiteboard or a piece of white paper. You're going to take a picture of it and upload it to Firefly. So the next application problem says, there were 3 friends at Ariana's party. Some more came after soccer practice. Then there were 8 friends. How many friends came to Ariana's party after soccer practice? Explain your thinking using pictures, numbers, and words. So friends, you're going to do the same thing on your whiteboard or your piece of paper that we just did. It's just a different problem. But I really want you to check to make sure you've included pictures, numbers, and words in your application problem. Can't wait to see all your hard work. Bye, friends.